NASA says its Voyager One probe, the most distant human-made object in the universe, is sending usable information to Earth again.
So at the minute, it's what we call health and engineering data. So it's, is everything else working?
Voyager has just sent back signals that reveal space isn't as quiet and calm as we thought. It's alive with shocking forces. After traveling more than 14 billion miles, Voyager One has crossed into interstellar space, uncovering intense magnetic fields and strange energy waves. Could this discovery mean we've misunderstood the cosmos all along? Let us dive into this groundbreaking revelation and uncover the truths that confirm the existence of a deadly alien life. What Voyager found in interstellar space. One of the most stunning revelations is a new magnetic field at the boundary of interstellar space. Scientists thought the sun's magnetic influence would fade as Voyager crossed the heliopause, but instead the spacecraft found a stronger, more complex magnetic force. This discovery challenges everything we thought we knew about the solar system's outer edge and the interstellar environment. The implications go far beyond academic curiosity. They touch on how we protect Earth from cosmic radiation and what's possible for future space travel. Could this newfound force offer opportunities, or does it signal dangers we've yet to understand? Before we delve into this, it's clear that what Voyager has uncovered is far more groundbreaking than anyone predicted, and this won't be the only discovery that will leave you stunned. Cosmic rays, high-energy particles linked to violent cosmic events like supernovas, are another surprising find. As Voyager passed into interstellar space, it encountered a spike in cosmic ray intensity. The solar system's protective shield, once thought to deflect much of this radiation, seems weaker than anticipated. This raises unsettling questions. Are future astronauts prepared for such radiation? Could these rays indicate an even larger, unseen threat lurking in the universe? These findings emphasize how little we know about the conditions beyond our solar system and highlight the risks of venturing further into space. The data also reveals a chaotic interplay of magnetic fields and plasma at the heliopause, contradicting the long-held belief that this boundary would be smooth and predictable. Instead, Voyager's instruments have detected bizarre fluctuations that defy current scientific models. These irregularities could represent forces we don't yet understand, with implications not only for space exploration, but also for Earth's safety. As space agencies like NASA and private companies like SpaceX push toward Mars and beyond, these findings demand a reassessment of how we approach interstellar missions. For decades, Voyager has been a symbol of human ingenuity and exploration. Its unexpected discoveries underscore the spacecraft's remarkable resilience and the brilliance of the scientists behind it. Even at a distance where signals take nearly a day to reach Earth, Voyager continues to transmit valuable data. This achievement highlights the meticulous engineering and planning that went into the mission, but it also raises questions about how much longer the spacecraft can operate. With its power reserves dwindling, we may soon face a gap in the vital information Voyager provides. Despite these challenges, Voyager's findings could revolutionize our understanding of the universe. The anomalies it has uncovered, from fluctuating magnetic fields to unexpected radiation levels, might hold clues to unlocking new propulsion methods or protective technologies. These advances could pave the way for safer and more ambitious space exploration. But the discoveries also force us to confront the harsh realities of deep space. What if these forces aren't just phenomena to study, but active threats to human survival in space? How do we balance the drive for exploration with the need for safety? The rise in cosmic ray intensity near the heliopause isn't just a problem for future astronauts. It has broader implications. Increased radiation could disrupt Earth's satellite systems, GPS networks, and global communications. Imagine a world where technology we rely on daily becomes unreliable, all because of forces from deep space. These risks highlight the interconnectedness of space and Earth and the need for comprehensive strategies to address them. The ethical questions are equally significant. Should we continue to push the boundaries of space exploration when the dangers are so poorly understood? What responsibilities do we have to the astronauts who will face these risks? Voyager's path also challenges our understanding of the interstellar medium, the matter and energy that fill the space between stars. Its instruments have detected irregularities in how solar wind interacts with cosmic dust, hinting at forces we've never encountered. Could these forces be remnants of ancient cosmic events or something entirely new? The answers could redefine our understanding of the universe's structure and history, but they also bring uncertainty. If these forces are more dangerous than anticipated, they could jeopardize missions to the Moon, Mars, and beyond. Yet it's not all doom and gloom. The data Voyager sends back could help scientists develop technologies to mitigate these risks. For example, understanding the behavior of cosmic rays and magnetic fields might lead to innovations in spacecraft shielding or radiation protection. These advancements could make long-term space travel safer and more feasible. Additionally, studying these forces might reveal new methods of propulsion, allowing spacecraft to travel faster and farther. In this way, Voyager's discoveries are both a warning and an opportunity. The urgency of these revelations cannot be overstated. As private space ventures and national space agencies ramp up their ambitions, the risks highlighted by Voyager demand immediate attention. Missions like SpaceX's push for Mars colonization or NASA's Artemis program to return humans to the Moon must account for the harsh realities of interstellar space. The stakes are enormous. If we fail to address these challenges, the consequences could be catastrophic, both for space exploration and life on Earth. The Voyager missions remind us that exploration comes with risks and rewards. Their findings challenge us to think bigger, adapt faster, and prepare better. As humanity stands on the brink of a new era in space, Voyager's legacy serves as a guide and a caution. The universe is vast, unpredictable, and full of wonder, but it's also a place of immense danger. The question isn't whether we'll continue to explore, but how we'll ensure that exploration benefits all of humanity. Voyager's greatest contribution may not be its data, but the questions it forces us to ask. What else is out there, waiting to be discovered? Are we ready for the challenges that come with venturing into the unknown? And perhaps most importantly, how can we use this knowledge to secure a better future for Earth and beyond? The answers to these questions will shape the next chapter of human history, one written among the stars. What Voyager found makes us wonder about how humans first started exploring space and what they learned along the way. How we reached for the stars. Humans have always been drawn to the stars, staring up at the night sky and wondering what lies beyond. But let's be honest, for most of history, all we could do was guess. Then came the 20th century, and suddenly technology gave us the tools to actually go there. Rockets, giant roaring machines, made it possible to escape Earth's grip and venture into the great beyond. The real game changer happened in 1957 when the Soviet Union launched Sputnik 1. This little metal sphere didn't do much. It beeped as it orbited Earth, but it was enough to send shockwaves across the globe. For the first time, humans proved that they could place something in space, and that opened the floodgates for exploration. 4 years later, Yuri Gagarin, a Soviet cosmonaut, became the first person to leave Earth. His trip around the planet lasted 108 minutes, but it changed everything. Humans weren't just looking at the stars anymore. We were part of that vast universe. Not to be outdone, the United States jumped into the space race. In 1961, Alan Shepard became the first American to reach space, though his flight was brief, just 15 minutes. A year later, John Glenn orbited Earth 3 times, showing the world that America was serious about this whole space thing. These missions, part of NASA's Mercury program, were all about figuring out if humans could handle space and survive it. Spoiler alert, they could. The rivalry between the United States and the Soviet Union pushed space exploration to new heights. In 1963, Valentina Tereshkova became the first woman to orbit Earth, spending 3 days circling the planet 48 times. It wasn't just a win for the Soviet Union, it was a huge step for women in space. But the most iconic moment of the space race came in 1969 when NASA's Apollo 11 mission landed astronauts on the Moon. Neil Armstrong's words, "That's one small step for man, one giant leap for mankind," were broadcast to millions. It wasn't just a moon landing, it was a declaration that humans could dream bigger than ever before. After the moon landings, the focus shifted from quick trips to long-term stays. In 1971, the Soviet Union launched Salyut 1, the first space station, allowing cosmonauts to live and work in space for extended periods. NASA followed with Skylab in 1973, where astronauts spent missions lasting up to 84 days. These floating labs were more than just cool hangouts. They were stepping stones for future exploration. In 1981, NASA introduced the Space Shuttle program, a new era in space travel. These reusable spacecraft carried astronauts and cargo into orbit and returned to Earth for refurbishing. They deployed satellites, repaired the Hubble Space Telescope, and even helped build the International Space Station. But the program wasn't without tragedy. The Challenger disaster in 1986 and the Columbia disaster in 2003 were grim reminders of the risks involved in exploring space. Speaking of the International Space Station, it's a marvel of collaboration. Operational since the early 2000s, the ISS brings together space agencies from the United States, Russia, Europe, Japan, and Canada. It's a laboratory for cutting-edge science, from studying human health and microgravity to testing technologies for future missions. It's also a symbol that space exploration isn't just about competition, it's about working together to achieve the impossible. In recent years, private companies have shaken up the space scene. SpaceX, led by Elon Musk, made waves with its Falcon rockets and Dragon spacecraft. In 2020, its Crew Dragon became the first privately built spacecraft to carry astronauts to the ISS. That wasn't just a milestone, it was a game changer, proving that spaceflight wasn't just for governments anymore. Other companies like Blue Origin and Virgin Galactic are developing spacecraft for suborbital flights, aiming to make space accessible to regular people. Well, at least those who can afford a ticket. Looking ahead, the future of space exploration is bold. NASA's Artemis program aims to return humans to the moon, with plans to land the first woman and the next man on the lunar surface. This isn't just about planting flags and collecting rocks. It's about establishing a sustainable presence on the moon as a stepping stone for missions to Mars. And Mars? That's the ultimate prize. Governments and private companies alike are racing to develop the technologies needed to send humans to the Red Planet. Beyond exploration, space has given us countless advancements that have changed life on Earth. Satellites have revolutionized communication, weather forecasting, and navigation. Research conducted in space has led to breakthroughs in medicine and materials science. Every step we take in space brings new knowledge and innovations that ripple back to benefit humanity. The story of human space exploration is far from over. From the first satellite to the dreams of walking on Mars, our path is a testament to curiosity and determination. Space is vast, strange, and full of challenges, but it's also a reminder of what humans can achieve when we dare to dream big. And as we look to the future, one thing is certain: the best is yet to come. Exploring space helped us find strange planets far away, each one more amazing than the last. The strangest planets ever discovered. Astronomers have been on a roll lately, uncovering incredible exoplanets that make us rethink how bizarre and diverse the universe can be. These distant worlds come in all shapes and sizes, offering everything from iron rain to boiling lava oceans. Each discovery pushes the boundaries of what we thought was possible, revealing just how wild the cosmos really is. Take WASP-76b, for example. This is no ordinary gas giant. Temperatures there get so hot that iron actually vaporizes and falls as rain on the planet's cooler night side. Picture an endless storm of molten metal. That's WASP-76b. Orbiting its star in less than 2 Earth days, this planet is a fiery inferno spinning around at breakneck speed. Then there's LHS-3154b, a massive planet weighing 13 times as much as Earth. What makes it even stranger is that it orbits a tiny star that's 9 times less massive than our Sun. Scientists are scratching their heads over how such a massive planet could form around such a small star. It's a mismatch that defies the usual rules of planetary formation. Now let's talk about Beta Pictoris b, a gas giant about 12 times heavier than Jupiter. Astronomers have managed to capture 75% of its 23-year orbit on video, condensing it into just a few seconds. It's like watching a cosmic racetrack, giving us a rare glimpse into the dance of planets around distant stars. The TRAPPIST-1 system is another gem. It boasts 7 Earth-sized planets, but not all of them are as promising as they sound. TRAPPIST-1b and TRAPPIST-1c seem to have lost their atmospheres, likely due to their star's intense radiation. This makes us wonder how harsh conditions can strip a planet of its potential for life. Speaking of strange atmospheres, Gliese 1214b has one of the thickest cloud layers we've ever seen. This mini Neptune is likely shrouded in haze, making it tough to study. But scientists think it might be rich in water vapor, hinting at the wide variety of planetary atmospheres out there. LTT 97. 79b is another showstopper. This ultra-hot world reflects a staggering 80% of the light from its star, earning it the nickname Cosmic Mirror. Its metallic clouds are the reason for its shiny appearance, making it one of the most reflective planets we've ever found. Kepler 10b is a rocky nightmare. Its proximity to its star means its surface is likely covered in lava, baking at unimaginably high temperatures. Forget life. This is a planet straight out of a sci-fi disaster movie. Upsilon Andromedae b offers a different kind of horror. This gas giant experiences extreme temperature swings between its day and night sides. One side is scorching hot, while the other is freezing cold, creating a world of fire and ice. And then there's 55 Cancri, where a year lasts only 18 hours. This planet is so close to its star that its surface might be studded with diamond-like structures, thanks to its carbon-rich composition. It's a sparkling, deadly furnace in space. Kepler 78b also hugs its star incredibly tightly, much closer than Mercury is to the Sun. Scientists can't figure out how it even exists, as current theories of planet formation don't account for such extreme orbits. It's a head-scratcher, to say the least. Much of this groundbreaking research comes from missions like NASA's Kepler Space Telescope, which has identified thousands of exoplanets over the years. Thanks to tools like the James Webb Space Telescope, we're now getting even closer looks at some of these far-off worlds. Webb has been particularly useful in studying planets in habitable zones, like those in the TRAPPIST-1 system. The hunt for habitable worlds is more than just a scientific endeavor. It's a quest to understand our place in the cosmos. Are we alone, or is life thriving on some distant exoplanet? As telescopes get sharper and space missions more ambitious, we might finally get some answers. Every time we learn something about space, it brings new questions that make us rethink what we know about everything around us. Exploring the unknown forces of space. The universe is a strange, endless expanse filled with questions that seem impossible to answer. Some of these questions sit right at the edge of what we know, teasing us with their complexity. Let's start with the so-called Big Bang. Scientists say the universe exploded into existence about 13 billion years ago. But if that's true, then what came before the bang? Was there an empty void or something we simply don't have the tools to understand yet? This one question has stumped even the brightest minds, and it's just the beginning. Now picture the universe as a giant, constantly growing balloon. It's getting bigger and bigger every second, and nobody knows what's causing it. They call this strange force dark energy. Even stranger is the stuff called dark matter, which makes up most of the universe but doesn't shine, reflect, or emit light. How do you study something that's completely invisible? Scientists only know it's there because of the way galaxies move, as if they're held together by an invisible glue. These two forces, dark energy and dark matter, remain some of the universe's biggest questions. And then there's the idea of the multiverse. What if our universe is just one of many? Some believe there could be infinite universes, each with its own set of rules. Maybe there's a version of you living a completely different life in one of them. But here's the catch. We don't have any way to prove it. It's like trying to guess what's behind a locked door with no key. For now, it's just a wild idea, but it's one that makes you wonder what else could be out there. Let's talk about time. We're used to thinking of it as a straight line, past, present, future. But some physicists believe time could be flexible, bending and twisting under the right conditions. Could time travel actually happen? If so, where are the time travelers? Would they even look like us, or would the process of traveling through time change them entirely? Understanding time might be the key to unlocking many of the universe's questions, but it's a challenge that's far from solved. And what about life beyond Earth? With countless stars and planets out there, the odds of us being alone seem slim. We've sent probes to Mars, searched for radio signals, and studied planets that might have water. But so far, no signs of alien life. Maybe it's hiding, or maybe we're just looking in the wrong places. Or worse, maybe we're the only ones in this vast, empty universe. It's a lonely thought, but it's one that keeps scientists searching. Speaking of extreme, let's not forget black holes. These cosmic monsters are places where gravity is so strong that not even light can escape. Once something falls into a black hole, it's gone. Or at least that's what we think. What happens inside a black hole? Does the matter get destroyed, or does it go somewhere else entirely? Some theories suggest black holes could be portals to other parts of the universe, or even other universes. It's a mind-bending idea, but for now, black holes remain one of the universe's most terrifying and fascinating problems. Then there's the issue of the universe's ingredients. We know about elements like hydrogen and helium, which make up most of what we see. But there are still gaps in our understanding. For instance, there's less lithium in the universe than we'd expect based on our models. Why? Did it get used up, or was it never there to begin with? It's a small detail, but solving it could change the way we understand the universe's history. Galaxy formation is another question. We have theories that explain how galaxies come together and grow, but there are still plenty of gaps. Ancient tech, new mysteries. Our understanding of space hasn't just appeared out of thin air. It's been a long journey, and Voyager One's latest encounter with a bizarre, unidentified force could reshape the way we think about the universe. Without the incredible voyages of spacecraft like Voyager, humanity would be stumbling in the dark about many of the mysteries of the cosmos. But after decades of groundbreaking exploration, it seems one of these probes might be hitting a snag. The next revelation could shatter everything we thought we knew about the boundaries of our solar system. Voyager 1 and its twin, Voyager 2, are two of the most iconic space probes ever launched. These machines have been out there for over 45 years, sending back data that has expanded our understanding of space in ways scientists could only dream of when they were first launched in the late 1970s. It's mind-blowing to think about how they've endured so long, especially considering the primitive technology they carry compared to today's standards. Back then, there were no smartphones, no internet, and no cutting-edge microprocessors. These probes were built to last, and last they did. Voyager 1 left Earth in 1977, and since then, it's been pushing the boundaries of what we know about the solar system. Initially expected to last just a few years, its mission has stretched on for decades, providing unprecedented glimpses into planets and moons we could barely imagine. The spacecraft managed to complete its tour of the giant planets, capturing iconic images and groundbreaking data before heading into uncharted territories beyond our solar system. In 12 years, a fraction of what scientists originally anticipated, Voyager 1 reached the edge of the solar system. It was the first spacecraft to venture into this dangerous zone where risks of malfunction and the possibility of being lost in the vastness of space were very real. While its twin, Voyager 2, charted its own unique course, Voyager 1 took the more treacherous path. This gamble paid off, granting humanity its first glimpse of what lies beyond the protective bubble of our solar system. These probes are the ultimate storytellers of space exploration. They've revealed hidden treasures like the violent volcanic activity on Io, a moon of Jupiter, and the tantalizing presence of water beneath the icy crust of Europa. Voyager 1's encounter with Saturn offered stunning insights into the planet's 10-hour days and rapid wind speeds. It even discovered 10 previously unknown moons. Every bit of data sent back from these distant explorers added a new chapter to the ever-expanding book of space science. Voyager 1's path eventually diverged as it veered toward the heliosphere, the vast bubble-like region surrounding our solar system. This region acts as a protective shield, safeguarding Earth and its neighboring planets from the intense radiation of interstellar space. Passing through this boundary was no easy feat, but Voyager 1's resilience proved extraordinary. Despite being over 12 billion miles away from Earth, it continues to send back data, albeit with occasional hiccups. Now let's talk about the nitty-gritty of Voyager 1's design. It's almost laughable to think about how basic the technology on board is compared to today's gadgets. There are no fancy processors or sleek touchscreens here, just hardwired systems that were considered cutting edge in the 70s. Its 8-track tape recorder stores the data, and the probe's instruments run on the equivalent energy of a refrigerator light bulb. Yet, this simplicity might be the key to its incredible longevity. By eliminating complex software that could fail over time, the engineers ensured the probe could keep ticking year after year. But as sturdy as Voyager 1 is, time is catching up. After 45 years in the harsh conditions of space, it's no surprise that issues are starting to pop up. Recently, scientists noticed that Voyager 1's data transmissions were weird. The spacecraft's antenna still points toward Earth, and the signal remains steady, but the information it's sending back is garbled and nonsensical. It's like trying to read a letter written in a language no one knows. This isn't just a minor glitch. The strange data suggests something more significant might be going on. Scientists believe the probe's attitude and articulation control system, the bit that keeps its antenna pointed toward Earth, might be the source of the problem. But the why and how of this malfunction are still mysteries. Could it be the probe's age, or has it encountered something out there in the vast unknown? The challenges Voyager faces now show just how hard and amazing exploring the unknown can be. Golden records and dying signals. Let's not forget, Voyager's journey has taken it into interstellar space, a region no spacecraft had ever explored before. It's a hostile environment filled with high-energy particles and intense radiation. Even with its sturdy design, exposure to these conditions for decades could lead to wear and tear. But here's the kicker. This pioneering probe was built to handle some serious space punishment. Its systems were designed to resist damage from radiation and high-energy particle strikes. So what's causing the glitch now? As scientists investigate, the team has been careful not to jump to conclusions. The craft's age makes it prone to issues, and this latest problem could be nothing more than a hiccup in its ancient systems. On the other hand, there's always the tantalizing possibility that this trailblazer has stumbled upon something entirely new and unexpected in interstellar space. Regardless of the cause, the probe's ability to keep functioning is a testament to the brilliance of its creators. Every day it continues to operate, it is another day of invaluable data collection. Its power supply, which comes from decaying plutonium, diminishes by about 4 watts each year. To conserve energy, scientists have been systematically shutting down non-essential systems. Despite these challenges, the spacecraft soldiers on, defying the odds. The eventual end of this mission is inevitable, and scientists estimate it will retire by 2030. Until then, the craft's faint whispers from the edge of the solar system will continue to enrich our understanding of the universe. For now, scientists are focusing on decoding the cryptic messages it's sending, hoping to squeeze every last bit of knowledge out of this remarkable explorer before it finally goes silent. This saga is one of human ingenuity and perseverance. It's a reminder of how much we can achieve with determination, creativity, and a touch of audacity. As it drifts further into the unknown, its legacy will remain as one of the most extraordinary chapters in the history of space exploration. But let's not overlook the twin that has also been busy making history. The companion probe has carved its own path, unveiling the secrets of Uranus and Neptune. While Neptune was long considered a planet of little importance, this second spacecraft shattered that misconception by revealing its dynamic weather patterns and surprising energy. Scientists marveled at how a planet so far from the sun could display such varied climates. It's discoveries like these that keep reshaping our understanding of the cosmos. By the early 2000s, both explorers had ventured into the farthest reaches of our solar system. They entered a region known as the termination shock, where solar winds slow dramatically. This was a milestone moment, as it marked the boundary between our solar system and the interstellar medium. The solar winds, once blazing at millions of miles per hour, slowed to just a few hundred. It's in this eerie transition zone that the two continued their groundbreaking work. Even as they edge closer to retirement, these pioneers' instruments remain active, sending back data that challenges our understanding of space. Their sensors have detected particles and magnetic fields in ways that provide clues about the nature of interstellar space. The data from these regions is sparse, but incredibly valuable. Every fragment of information helps paint a clearer picture of the environment beyond our solar system. The golden records carried by both spacecraft are another fascinating aspect of their journey. These records contain sounds, images, and messages from Earth, intended for any extraterrestrial life that might encounter the probes. The thought of these records floating through space, potentially for millions of years, is both humbling and awe-inspiring. They serve as a time capsule of humanity, a snapshot of who we were at the time of their launch. But back to the technical marvels of these explorers. The simplicity of their design has been a blessing and a curse. Their lack of modern computing power means they are limited in what they can do, but it also makes them less prone to certain failures. The engineers who built them had to think creatively, using the technology of the time to craft machines that could survive the rigors of space. This ingenuity is evident in every aspect of their design, from their durable power systems to their robust communication arrays. One of the most remarkable aspects of their journeys is their endurance. They were not supposed to last this long. The fact that they are still sending data after nearly half a century is a testament to the foresight and skill of the people who built them. Their continued operation is a reminder of what can be achieved with determination and a bit of luck. As the two drift farther from Earth, communication becomes increasingly challenging. It now takes over 20 hours for a signal to travel from the lead craft to Earth, and this delay grows with each passing day. The faint signals are a testament to the vast distances involved. Yet, despite these challenges, the data they send is as valuable as ever. Each bit of information adds to our understanding of the cosmos and our place within it. As Voyager fades, the focus turns to a fast-changing space race filled with bold plans and fierce competition. The new space race. Space, once a mysterious and untouched frontier, has turned into a high-stakes battleground. Recently, warnings have surfaced about China's potential military ambitions behind their seemingly civilian space programs. Meanwhile, the Chinese military has fired back, accusing the United States of militarizing space with a network of advanced spy satellites, allegedly tied to Elon Musk's SpaceX. Beneath all the buzzwords and political back and forth, the truth is clear. A new kind of space race is unfolding, and it is not the United States and Russia rivalry of old. This time, it is the United States squaring off against China, with the future of humanity's reach into the cosmos hanging in the balance. But what is really going on up there? China's space game is not just about flashy rockets and bold missions. Their space agency, the China National Space Administration, has been quietly making waves that feel straight out of a science fiction movie. Back in 2019, they landed a spacecraft on the dark side of the moon. Fast forward a few years, and they are gearing up for their Chang'e 6 mission, aiming to grab lunar samples from untouched regions. These are not just cool science experiments. They are opening doors to rare minerals and isotopes that could flip the global energy scene on its head. Imagine China mining the moon for resources so valuable they could power the world for centuries. The question is, who is going to stop them from keeping it all to themselves? But the moon is not enough. In 2021, China's Zhurong rover made history by rolling across Mars, proving they are not afraid of big, bold moves. Their plans to send humans to Mars by 2033 make it clear that exploration is just the start. Control of space's most valuable real estate might be their endgame. For decades, space seemed like the ultimate neutral zone. That dream is fading fast. China's military might is not just grounded on Earth anymore. They have introduced the White Emperor fighter jet, which, if claims hold water, can deliver weapons from orbit. Analysts warn this could make traditional defense systems obsolete. And then there is their satellite swarm technology. Picture this: fleets of tiny satellites capable of knocking out enemy systems mid-orbit. If a geopolitical crisis breaks out, your global positioning systems, internet, and trade networks could be toast. The implications are as chilling as they are game-changing. Even Elon Musk's Starlink, marketed as a tool for global internet access, has raised eyebrows. Its potential as a decentralized defense network highlights how blurred the lines between civilian and military uses can become. Space is not just the final frontier anymore. It is the next big battlefield. China's ambitions are not just about planting flags on distant worlds. They are eyeing the moon as a treasure trove. Specifically, they are chasing helium-3, a rare isotope found in lunar soil that could revolutionize energy production. Unlike old-school nuclear power, helium-3 fusion promises nearly limitless energy with little waste. This is not a dream. It is a trillion-dollar industry in the making. China's planned lunar base, set to be operational by 2030, is more than just a science station. It is a foothold for mining and resource control. Partnering with Russia, they are setting the stage for long-term habitation and exploitation of the moon's bounty. But what happens if they corner the market on these critical resources? Will they use this power to uplift humanity or leverage it for dominance? History suggests the latter, turning space's promise into yet another stage for global power plays. China's vision extends beyond the moon. They are diving into space-based solar power, testing components for orbital power stations in 2024. This technology could capture the sun's energy without pesky earthly interruptions like clouds or nighttime, beaming it back to the planet as microwaves. The promise of unlimited clean energy is tantalizing, but the catch is control. Whichever nation masters this first will not just revolutionize energy markets. They will hold a bargaining chip unlike any other. Will this spark collaboration, or will energy become the latest tool of geopolitical leverage? Given the stakes, it is hard to imagine the former. China's edge in space exploration is not just about rockets. They are wielding artificial intelligence like a precision tool. Their Tiangong space station, slated for full operations by 2025, is designed to rely heavily on artificial intelligence for tasks ranging from maintenance to data analysis. Their Mars rover Zhurong already outperforms some of the National Aeronautics and Space Administration's technology thanks to its autonomous navigation. This centralized, government-backed approach gives China a significant advantage. Meanwhile, private players like Musk's SpaceX are also leaning on artificial intelligence for interplanetary missions. The question is whether decentralized systems can keep pace with China's tightly coordinated efforts. Whoever wins this artificial intelligence race could shape humanity's future in space, for better or worse. Low Earth orbit is becoming a crowded and contested space. Musk's Starlink network, celebrated for its potential to connect the unconnected, now faces stiff competition from China's SpaceSail, set to launch by 2026. While Starlink operates as a private venture, SpaceSail is backed by the Chinese government, raising alarms about its potential for surveillance or even cyber warfare. If SpaceSail overtakes Starlink, the implications could ripple across the globe. Will these satellite networks create a connected world or deepen the divide, splitting the internet into competing spheres of influence? The answer will likely determine how the digital age unfolds. As nations push further into space, the stakes are higher than ever. The choices made today will decide if the cosmos becomes a realm of cooperation or yet another stage for human conflict. Space exploration offers the promise of unity, but rivalries over resources and technology risk overshadowing that potential. The battle for satellite supremacy is far from over. Will space sails rise, usher in innovation, or ignite new conflicts in space? Share your views. Like, comment, and subscribe for more on space exploration and technology.